Our next section is on ellipses, and an ellipse is basically like an oval shape, and it has the property that the sum of the distance from two fixed points, or what are called foci, is constant for all points on an ellipse. So if you look at the picture here, we are drawing from the foci to the ellipse, and this length and this length are different. This length and this length are different. However, the sum of the lengths will be the same. And that's really true for any points on the ellipse. So it has some applications because it has a reflection property, and any sound or light that's emitted from one focus will reflect and hit the other focus. So if you look at the picture here, we will have a center, and we have the foci or focuses, and then we have a major axis and a minor axis. And the major axis is the longer axis, and the minor axis is the shorter one. And the major one will not always be the horizontal one. In this diagram it is, but sometimes the major axis can be vertical. So we need to be careful of that. And the vertexes will always be on the ends of the major axis, and the co-vertices will always be on the ends of the minor axis. Okay, so we have our formula for the ellipses. So our equations need to be in this form, and then we can read the information from them. So our center will be HK, the horizontal distance from center will be A, the vertical distance from the center will be B, the major axis is the longer length, again sometimes it's vertical, sometimes it's horizontal, the minor axis is the shorter length, so the vertices are always on the ends of the major axis, co-vertices are always on the ends of the minor axis, and then to find the foci, if the major axis is horizontal, we need to add and subtract C from H in the center, and C is going to be equal to this. And then if the major axis is vertical, we need to add and subtract C from K, where C is equal to this. So a lot of information. I would probably pause the video and just read through all this information yourself. So let's now look at number 1. So I'm first going to identify my H, K, A, and B. So my H is equal to 3, and I'm looking right here. And my K is equal to -2. Now it's a -2 because there's a minus in the formula. So we need to do the opposite sign of whatever we see here. So because it's a +2, we need to put a -2. And my A is equal to 3 because 3 squared is 9. And my B is equal to 5 because 5 squared is 25. So my center is 3, -2. The horizontal distance is 3, and the vertical distance is 5. So I'm going to graph this. So my center is here at 3, -2, and then I'm going to use my horizontal distance of 3, and that's going to be from the center. So I'm going to go 3 to the right, 3 to the left, and then my vertical distance is 5. So from the center I'm going to go up 5 and then down 5. And I'm going to draw this. So the longer length is the vertical length. So that means that that is the major axis. So that's actually just going to be 10 units long, and if you just want to multiply the vertical distance by 2 to get that, you can as well. If you just want to look at the graph, that's fine. So 2 times 5 is 10. And the minor axis is the shorter length, and that's the horizontal length. And you can see that that's 6 across, which is taking the horizontal distance and multiplying it by 2. So 2 times 3 is 6. And the vertices are on the ends of the major axis. So these are my vertices, and those are the points 3, 3, and 3, -7. And then the co-vertices are on the ends of the minor axis. And here was the center. So the co-vertices are 0, -2, and 6, -2. So lastly, I need to find my foci. So I'm going to use the formula c is equal to the square root of b squared minus a squared. And I'm doing this because the major axis is vertical. So c is equal to the square root of 25 minus 9, or c is equal to the square root of 16, or c is equal to 4. So my foci will be 3, -2 plus 4, and 3, -2 minus 4. So that's going to be 3, 2, and 3, -6. So let me put those up here. And then label them on the graph.